Thank you very much. I hope everyone can hear me and everyone can see my presentation. Great, thanks, Jana. Yes, thank you for having igus on this panel. And thank you very much to all of you to introduce this topic that lets me jump in right into one topic. I want to present you a little bit about shore power system for container vessels and especially about our igus mobile shore power outlet. Yeah, first of all, it's similar to what George just mentioned. It's the overall context of shore power for a special terminal. So when we're thinking of a container terminal, it's all about profit. It's unloading and loading vessel as fast as possible. Safety first, yes, but then comes automation. Electrification is happening already. All the port equipment is going to be electrified, no matter what. 4.0, big data, it's happening. It's happening, and it's probably overtaking everything else. But going green, zero emission is a big target for the future, for all of the ports, and there's commitment from terminal operators, from shipping lines, and from the port authorities. But when we're thinking about shore power, it somehow has to fit into this environment, and we need to address the overall context. What kind of problems we are facing? The main issue is that the cable management system that is placed on board the vessel of a container ship has a limited deployment length. So in the end, it depends on the site location, on the design of the wharf, and also on the tidal range, because that can be very, very different compared to Hamburg and Kiel, for example, or from Vancouver to Marseille. So you can have a big tidal range, and this can sum up more than 20 meters of movement of the vessel that is needed to compensate this movement. And then you have limited reach for the plugs to plug them in at any place. That leads to the main problem of all the shore power connections, not only for container vessels, but we see this also on cruise vessels. And we have different solutions to address that, but the connection dilemma is really a key issue for all of the ports and designing a shore power system. So you have, every day you have different calling vessels in terms of size, berthing starboard, berthing port side, and then the location of the cable management system on board the vessel can be at various points as well. So in the end, you don't know where to connect the vessel. So not today, but not tomorrow, and foreseeing the future with new vessels calling or new lines calling this berth, it gets even complicated. How does it start and what can we learn from the past? So in the past, what we can see here is my colleague doing a connection in Port of Auckland in California. We installed outlets in the terminal. But if the vessel doesn't line up, you whether have to move the vessel or you have a lot of people coming out. And again, 21st century modern container terminal, how does it work with your operation? I don't think that many people coming out to do the connection is something you're looking for. If you think about the coverage, what you can achieve with placing every 50 meters an outlet, what doesn't not only cost a lot of money, but also in terms of operation, you create sort of red zones where you cannot connect. So in the end, you have to move the vessel or you cannot connect. And even getting close to it, these cables are super heavy. They weigh 10 kilos per meter. These are 2 cables. It's not easy to move them. You can do this coming from the vessel about 3 to 4 meters. That's fine. You get this done. But afterwards, I mean, you definitely need help. You need to call your colleagues. When we're looking at the situation that what some of the ports did in California, they acquired sort of an extension system. We built one as well. But most of the time, the terminals look like this. you simply don't have space. There's no space. George just mentioned this as well. It's really, really challenging. You have space about 2 meters, 1 meter 50. You cannot drive there something. There are bollards. It's impossible. What we learned from California, the regulation got stricter and stricter. So 2020, they had to connect 80% of the vessels. So they started putting an outlet at each end of the wharf or of the berth. And then they realized, okay, I have another vessel coming, and then the location is different. Then they added 2. Then they added 2 more. So in the end, they had 6 outlets. That's the main standard when you're looking into California. 6 outlets cost a lot of money, doing all the trenches, doing all the cabling, installing the outlets in the ground. But now CARB, Californian Air and Resource Board, requires 100% of connections. I mean, LA and Long Beach invested approximately 150 million US dollar, and it seems like they have to invest same amount of money to reach this goal, 100% of connection. Why is 100% connection important? Because otherwise they face penalties because they are not compliant to the regulations. But if you're thinking ahead and at different ports, because the key drivers for shore power can be different, but in the end, you want to utilize your infrastructure. So all the equipment you're installing, especially the electrical equipment, frequency converter, transformers, trenching, cabling, I mean, you want to get most out of your money, and you want to utilize this because in the end, it's all about selling electricity and connecting as much methods as you can and achieving 100% connection rate. And also 100% connection means 0 emission. So no one has a crystal ball, and we need to plan for the future. And so you need some kind of flexibility. And when Port of Auckland came to us and said, okay, we need a system that provides us the ultimate connection flexibility, we cannot add more volts. 1 volt is including cabling and installation and all is approximately 1 million US dollar. Maybe it's a little bit cheaper, but it's a lot of money for 1 volt. But also, they said that you can't make a Swiss cheese out of my terminal. There are cranes traveling over the deck, and there's a lot of steel in the ground, and it's not easy to dig any trenches and holes into the terminal. And they wanted to have a one-time investment for 20 years of lifetime, so one and done. Oops. So we started to analyze, and as Josh mentioned as well, we went there, did our studies, did the plugging, understood operation, learning how this could be done. And the only place where what we found and what was acceptable was we need to put a track element outside the trench and have a mobile shore power outlet that travels along to bring shore power to the vessel and not move the vessel to shore power. The next step was, after designing and proving all this concept, was building a system. And we actually, that's in our factory in Germany, where we created a test stand and installed a fully functional system with a 20 meter of travel, because everything is super heavy, everything is big. So it's a real challenge. It sometimes looks nice on paper, but you need to do the real thing to learn what it means to do this connection and to prove that every single step is working, because bringing this out there, then it has to work. And so the good thing is that we have an international standard and that we can follow a lot of guidelines in terms of also of safety and connection procedures and making the system safe, that we can address here in the systems. And the good thing is it's working. I mean, shore power is used since many, many years and has its procedure, and it's working safely, and it's used for many years. So it's not a brand new technology, but the question is how we can improve this technology, how we can be innovative to create, to supply a smart infrastructure for the needs of the future, to get most out of your money and achieve 100% of connections. As you can see here, we have also established this as a Kirky mechanism to avoid that the system can be powered on without being correctly connected, or that you can disconnect without that the power is shut down. So these procedures are all well established, and in all our systems, or in all shore power systems, you will find such methods. We are very happy to install our first systems in Port of Hamburg. It's very exciting for us. It's a great honor to do so, and yeah, we're looking forward to the future, to see it on a terminal running. One important issue is installing something outside the terminal. I mean, we make it flexible, but you also need to make it safe. So it's a very big challenge to really find a good solution for each port, because there is no port like another, just like George mentioned before. So analyzing the terminal and getting the experts on board in each field, from cabling, cable management system, but also from protecting the system. We collaborate here with Shibata Fender team, one of the two leading fender manufacturers worldwide. And there are many different solutions how you can protect the system. What needs to be assured that at 100% compression of the fenders, that's what they designed for, the system is protected and not damaged. And we can achieve that. We have studied a lot of different ports together with Shibata to achieve this goal, to make a reliable one-time investment solution for the future of the ports. To sum up, yes, we designed to this criteria. Again, IEC 8005, that's sort of the standard Bible. You find in the different annexes the requirements for different vessel types. We designed this according to the EU Machinery Directive, corrosion protection C5M, that's according offshore classifications, the highest corrosion protection, IP66, 67 for electrical components, Kirky integration, as well as push-pull force detection to measure the safety of the system, and a clear signaling status. This can be adapted to each country requirements in terms of certification, and we also do a certification of the overall system with DNV in the next months. Igus is a family-owned company located nearby Cologne. Frank, our owner and CEO, is working right among us. We are more than 4,000 people worldwide. Biggest companies next to Germany is our headquarters for the Asian region in China, as well in Singapore, and yes, certainly the States and Rhode Island. And yeah, we have done many shore power systems already for different vessels, and you need to do a good study to find the right system. And we are very excited about the development and the goal going green and zero emission of the ports, and hope that we can contribute a little bit to this goal. Thank you very much.